Welcome, welcome, Shaw. Thanks for being here. I'm excited after getting to I guess talk through watching your videos to a bunch of people on my podcast for you to be here and to tell me and everybody a little bit more about exactly what you do, because some of this I have learned and heard, but I think your brain is pretty extraordinary in this conservation tech space. So excited to get to talk to you today. So.
That's a real nice thing to say. Thanks. Yeah, no, I'm excited to be here and kind of talk about what we've been doing with Fieldkit for the last couple of years and Conservify for a little bit longer. All focused around how we can move forward the concept of conservation technology as a field and understand better ways that we can do it and make sure that conservationists and scientists and citizen scientists and curious citizens and all sorts of people all over the world have access to the tools to better understand it and explore it.
So I know a lot about you, but so could you talk some about your journey of basically starting in doing some stuff in the space industry, and then your transition to now working with Conservify as well as Fieldkit?
Yeah,
So
totally. Yeah, so I was the kind of kid that always knew I wanted to be an engineer, and so from a very young age, I was always into technology and engineering and everything associated with that. So when it came around time to go to college, I went to school for engineering, and you know I think one of the weirdest things in the world is when you ask an 18-year-old what they want to do for the rest of their lives. Is usually the decisions that they make are not based around the smartest motives. And so I picked chemical engineering because I liked chemistry, and I heard that if you worked in oil and gas, you could make a lot of money. So that was my initial decision.
I was there too. I did a petroleum engineering minor, and that's I'm there right with you. So.
Yeah. Yeah, and it was actually, during college that I started learning a lot more. I was just doing a general chemical engineering degree, and I started learning a lot more about the petroleum industry and all the kind of horrors associated with that. Um, and decided that I didn't want to do that, and went through my 4 years getting my chemical engineering degree. And at that time, when I left college, there wasn't a lot of options job wise for chemical engineering. The majority of the stuff that I was finding was things related to like wastewater treatment and stuff like that, which is like incredibly important work, and we all rely on it constantly. But I just was not inspired by taking that path. So I started looking in other areas where I could use chemical engineering, and ended up in aerospace. And so the first job I got out of college was at Boeing Satellite Development Center. So it's out here in LA, right by LAX, and it's a facility that builds anything that's like related to you know uh, satellites and communication satellites and all sorts of stuff related to that. So the facility is actually really old. So the cool thing about it is it was originally Hughes Space and Communication. So Howard Hughes started this facility. He took the old Nash automobile factory and turned it into the biggest satellite manufacturing plant in the world. And they did a bunch of firsts there. So like the first communication satellite was built there. Surveyor, which landed on the moon, was built there, and there's a bunch of stuff. But Boeing ended up buying it way down the line. Before I started working there, Boeing ended up buying it. It actually, the piece that used to be Hughes Space and Communications broke into three things. Boeing took the satellite manufacturing and design stuff. The radar and everything radar related went to Raytheon, and the third piece became what's now DirecTV. So that all that stuff came out of that facility. So I worked there for in total for 11 years.
Wow. Was that through interning, or were you
Yeah,
just kind
well,
of
I
straight
started
out
as an
of?
intern. Yeah, I
Yeah.
started as an intern, and then transitioned just straight to full time. Yeah, I was gonna go back to school for a master's and decided just to do it. At that time, all the companies like Boeing, they had like these crazy education programs. And so, they would pay for anything. Like there was people who got doctorates in theology that were paid for by Boeing.
Yeah. You just had to go to grad school, right? You just it's anything in grad school, just go into grad school.
Anything. Yeah. Anything. It's not like they stopped that after the crash in 2008. Like they don't do that any longer. But back then it was anything. So I was like, okay, well, I'm going to work full time and I'll go to grad school while I'm there, which I did. I went to USC and did a systems architecture and engineering degree, and then after that went to Stanford. And the whole time I was working at Boeing and studying, I was always looking for things to do with my engineering degree that I felt inspired by. The first thing that I was working a lot on was Engineers Without Borders. So I did a lot of work with Engineers Without Borders, doing solar power, clean water and sanitation projects in Malawi and Tanzania and India and all sorts of countries across the world, and really like that. And it was actually when I was going back to get my second master's at Stanford that I started understanding more about the issues around the gaps that they had around trying to gather critical data for conservation. So it was there that I started working with an organization based out of Stanford called the Center for Ocean Solutions. And they look at big kind of ocean problems. And I came in to help them look through the issue of illegal, unregulated and unreported fishing. So IUU fishing, if you've ever seen it.
Yeah.
So, and I did it with my engineering hat on. So started thinking about technology. That was like my very first step into conservation technology back in 2007 or something like that.
So I had the first class this week for me, and I started kind of talking to the students about conservation technology, and then I ended up realizing I needed to take a step back and talked some about human-centered design. So, which is could you talk some about is that kind of, because I feel like Engineers Without Borders is like the epitome of human-centered design in an engineering sense, where people understand it. And so could you talk some about your maybe human-centered design and how, because
Yeah, I mean, there's a couple things I think we should kind of break apart in what you just said. One is, so the work that groups like Engineers Without Borders was doing is kind of influencing a lot of the stuff that's happening in conservation technology. So, the use of accessible and kind of empathetic technologies has been very successful in the fields of public health and development. And so that's Engineers Without Borders kind of works mostly in the development field, but kind of a little bit in public health. And that allow, the successes that they've seen in those areas, we're trying to reproduce with conservation technology. So that's where we learned a lot about that. Now, what you're talking about with human-centered design, that's a different way to think about how you can create solutions, and those solutions might include technology and they might not include technology, that can really get at what the core needs are for the people who are impacted by it. Or, in the conservation sense, the ecosystems, the animals, the humans that are helping kind of protect these places, how you can create solutions, thinking through what their real heartaches are, what having what they call empathy for the user and understanding the user, and designing something that's going to actually help them meet their goals, and not necessarily something that you think will work better for them, or that
or is reapplied, right? Is like the opportunistic tech that you've talked about before, right? The it's for hunting, but let's just slap it there. Yeah, and I just thought it was really interesting because as an engineer, right, we always do this, we're going to go through the engineering design process. We're going to send a CAD model, and then they're going to, and you have all of this stuff. And a lot of the students had never even heard of that term before, which was interesting to me because the way I got exposed to it was through Engineers Without Borders, and then through things like food security and things that are probably more in the public or wastewater treatment, more in the public health, public sanitation, like the Bill and Melinda Gates, the foundation, the toilet, and some of those things that have made those things more popular. But I just thought it was interesting that maybe that's where, and this just goes for me from future conversations, but that's maybe where I have to start if somebody's at ground zero, is to kind of talk about kind of the bridge between going from human-centered design, something like Engineers Without Borders, and then now you take that and apply it to wildlife conservation. That's kind of maybe the groundworks of the roadmap, but I'm not sure if there's a one size fits all.
Yeah, I mean, I think it's really important to do that. Oftentimes, when you bring technology into an area or an industry or a community that hasn't quite used it before, there's a lot of incentive from a technologist or an engineer standpoint to say, hey, this is cutting edge. Let's use this here. Or like if we throw AI and drones and like all these kinds of sexy technologies at it, then we can create this solution that's going to solve everybody's problem. It's the Silicon Valley model, right? Where they think that they can just reimagine the way the world works, every little sliver of how the world works, by throwing a bunch of VC money, a bunch of technology at it, and just kind of creating these new things. And whereas like the people who do a lot of like human-centered design or some of this kind of deeper holistic sort of design thinking, they are the ones saying, no, that's not the right way to solve it. Like, you don't want to give a hammer to somebody who needs a ruler, right? Like, you want to actually understand what their core need is and how they can do that. And what you said about opportunistic is like, it's perfect. It's a perfect example of that, because I think in the early days of when the conservation technology movement was getting big, there was a lot of this kind of big bombastic, we should use satellites and drones and we should like re-engineer X, Y, and Z. And people would get excited about that, but nothing came from it, and that's a big problem.
So one of the ways it was explained to me that I really, really loved is somebody was talking about, well, hey, what I need a knife. And then somebody comes in and it's like, okay, here's a Swiss Army knife. And it's like, well, okay, well, all I needed was just like a 3-inch really sharp blade. And it's like, no, now you have everything that you could possibly want. You have 35 different devices that all kind of work okay, but we're giving you and it's like, but all I need right now is A, and I need A to work really, really well, without fault, without fail. And that's one of, I think, just the interesting perspectives, is the opportunistic tech. And the thing with this is actually, it's kind of funny to me, because when the way that students get into the classes, you have to apply, and every single person that applies is like, I've always wanted to do AI for wildlife. Like, that's it. That is, it could be a computer scientist, and they're like machine learning, AI, drones. It's like those three things are what every single person is like, that's what you're working on, right? And it's like, no, let's take a few steps back. Like, let's look at some of the things that we're building. And it's just very different, I think, than what a lot of people perceive, because there's like, in biology, right, the phrase is the characteristic megafauna, like the elephants, I know did a lot of field work in Africa, and it's like, then you have these reptiles and amphibians that are dying as well, but it's like, those are, slewed to the side a bit. But
yeah, I mean, honestly, I learned a lot of this approach through the Engineers Without Borders stuff that I did early on. I learned to understand the importance of assessment trips, of like understanding actually what the needs and the desires and the limitations and all these things around these projects. I like, that is such a key part of thinking through what these solutions look like. You know, there's a lot of times where people are like, oh, you should use machine learning for that, but or you should use a drone for that, when is like the only kind of reliable power to charge that drone is, you know, hours and hours away, right? I mean, I have an example, right? When I was doing a project, you know, 7 years ago or something, that was in the Caribbean, and it was around illegal fishing, monitoring the fishing that's happening around it. And at one point in the time we were on the island, they drove us to this area where they thought a lot of illegal fishing was happening, and it was happening right offshore. And we drove to this part of the island that entire half of the island had no reliable power. There was just no, it was more wild. There was no like, there was like campgrounds and stuff, but no structures and places where people lived. And they drove me up to this top of the hill. We all got out on the hill, and they said, okay, well, we want to create our drone launching point to be here. We want to build a little pad, and we can have our drone fly off and do monitoring of where the fishing goes. And we actually looked out, and I said, point to me where the fishing goes. They showed me the different areas. We could all see it from the cliff. We got in a boat. We went down and we saw it. And it turns out that, you know, a drone was the worst possible solution for these areas, because you know, they're up on a cliff. It was windy. There was no access to power to recharge batteries. And all of the illegal fishing that was happening was completely visible from the cliffside. So, you know, I was joking around, but in reality, like, what they really needed was they needed to pay a guy and give him a case of beer and have him sit on the top of the cliff and watch with a pair of binoculars. That's the solution. The solution isn't the drone, you know? And so we talk a lot about like how we actually think through what the real problem is and how we can actually solve for that problem, as opposed to just throwing big, flashy, shiny technology at it.
Well, and a lot of this goes to, like, if you think of the scientific method, I think a lot of just not just opportunistic tech, but almost like there's, I'm going to make up a word, but it's like conclusion tech, where you conclude at the very beginning of the scientific process what technology you need, and then you try and fit the actual problem. Oh, so we're just going to use drones for this. Let's see where we're going to deploy the drone. Let's go into the field. Let's look at the place. Where can we get electricity? Instead of, like, I forget what you said, but like going on that visit and looking at where can you actually implement it? What is the actual best technology? Maybe you hypothesize a drone is there, but you don't try and take the entire process. So the reason
it's the way that Engineers Without Borders just does, and we've at Conservify have accepted, like, basically co-opted this model, is anytime we have a new project in an area we haven't been before, we do this assessment trip. And that assessment trip allows us to gather critical data, test out small devices, understand things about the environment. You know, so some things you'd be interested in is like, you know, the level of sun that it gets. Like, would solar power be viable there? Are there cell networks or radio networks? Can we establish that? Is there reliable Wi-Fi? What's the kind of the technical capacity of local folks that we'd be working with there? Do they have any interest in this sort of thing? It even goes down to even understanding like what the past political situation is in the region. And so if you're, you know, working on projects where you're deploying expensive technology, but you're doing it in an area where the researchers that you're partnering with don't actually have a good relationship with the community, or they haven't been working with local collaborators, then like that's a recipe for disaster. So we just don't do it, right? We only work with people who are kind of dealing with the local community in a way that's bettering the situation that they have and providing value to people who, you know, you're asking to come and study their backyard.
And that's actually exactly where I wanted to transition into this. So we've talked about some issues that are in this space. And so where I want to kind of go from here is to talk about kind of think internally for you. So and you kind of read my mind, and so you already addressed some of them. But so what are y'all doing specifically at Conservify as well as with Fieldkit to kind of combat these things?
Yeah. So that's
I guess start with what is Conservify?
Exactly. Yeah. So basically, to continue on that story that I was telling you about my my career path. I started working in ocean conservation issues, and this was back in a time where like some of the technologies that I was investigating and talking about were not commonplace. So back then when you would talk about drones, there wasn't any DJI or any of these other companies. So like you would have to physically build your own drone, get an RC plane and add a autopilot sort of thing to it. And so like back then I was throwing out all these ideas and had research projects around that. One of them Nat Geo funded around using home built drones to kind of do coastal monitoring. And there was a bunch of other work that we were doing. And it was kind of through that stuff that I ended up becoming, one of the, like an emerging explorer through the Nat Geo program that they used to have. No longer there. And it was through there that I met a lot of people and started doing field work in a bunch of different places, including the stuff in Botswana that you were mentioning before. And it was during all of that time that this idea of developing conservation technology from scratch with conservationists as like the core user, this started becoming the main thing that I was focused on from a research perspective. And in 2015, I got some seed funding from Nat Geo and some other organizations to actually start Conservify. And Conservify is structured, as a nonprofit technology development lab and kind of makerspace and all that stuff, but who only works on conservation related projects. So, when we set up the lab, that was the first makerspace in the world that was just 100% devoted to conservation.
So real quick before you, I know what this is, but some people might. Will you talk about just what is a normal makerspace? Because I know exactly what that is, but talk about maybe some makerspaces that you're familiar with or other people might be familiar with, and kind of translate it.
Totally, yeah. I mean, basically, a makerspace is the traditional model of makerspace is like an organization, or like it's almost like a club model where you can buy into a monthly payment or something to get access to a lab that has a whole bunch of prototyping equipment. And so a lot of like the makerspaces that you see in bigger cities, they not only have things like 3D printers and laser cutters, but they also have like stuff for textiles and fabrics, and like it's basically geared towards people being able to come in from the community and use tools that are generally outside of the reach of a regular person, just because they're expensive and they require some sort of training to be able to run. And so, there's like really famous maker spaces, but the whole idea is that it creates a place that allows people to come and test out ideas and develop and kind of prototype things and find collaborators. Lots of universities have maker spaces.
Yeah, and so we have one at Georgia Tech, and just to kind of give some perspective of, it's not just like you pop in, but you have things like a lot of times it's not just when you're getting these services, if it's something that you pay for in like a big city, there's also usually people helping you learn how to operate the equipment or those sort of things. And so you're able to go in and you can, if you want to make, I don't know, let's say like a talking doll, there's like technology to develop the voice box, to manufacture and machine everything, so the textiles, and then you can kind of bring all of this stuff together for prototyping. So
and the other kind of added benefit that they bring is community, right? So they bring in a lot of times people will just hang out in maker spaces, and so you'll find like the same people always there. And that's really useful, because when you're banging your head against the wall trying to figure something out, you can just walk over and be like, hey, what do you guys think about this? How would you do this? Or like somebody can be like, oh, that's a cool idea. I can design something, in CAD that could work with that. And so it's a really cool thing. And so we built this, the idea behind Conservify is like, how can we create this lab, where it allows us to develop prototype technologies, like iterate, quickly manufacture things, and And this model is something that like you see in a lot of places like Boston and San Francisco around like product development. So like how do you make, you know, consumer product? How do you make smartphones or like things like that? They have these labs that are companies, for-profit companies that work with other organizations to design these sorts of things. And so we took that same model, but we wanted to only work on conservation projects or field science sort of things. And then we wanted it to be a nonprofit. And so those are the two things that we kind of did from a very first start with Conservify, to like basically develop these sorts of technologies for conservation. And everything that we do at Conservify is open source. So we're like, basically our goal is that if we're going to spend the time and effort to design and engineer something, then we're going to put all that information out in the world. They're going to, our code, our design files, like any documentation, all the stuff that we do there, so that anybody else can replicate it and build on it and expand and create their own version and all sorts of stuff.
And just so, I mean, we've talked about it, I feel like every single week, but it's unfortunately that's open source is not the norm. So some of the conversations and the things that was another thing that kind of occurred in showing this video is a lot of people are like, wait, everyone's got to do that, right? Like everything's open source, everybody's using human-centered design for all of this sort of stuff. And so what's really cool is you're kind of almost taking a lot of the cons of what, as we've talked about before, the last tens, hundreds of years of this opportunistic tech have been, and then using successful business models, but then making that, implementing those in a community that is doing human-centered design focused on wildlife. So it's really cool to kind of see, and I'm personally just really excited because what I hope is that there's aspects that you can take in, that makerspace, and then other people that are involved in other makerspaces can kind of take and realize, oh, there's other people that have this community. And like you said, I mean, it's kind of like coffee shops where, the socialization aspect of it too, which is really, really cool.
Yeah. And I mean, the cool thing is too, that like, conservation technology as an industry is pretty open, like pretty favorable to open source. So a lot of like the big players, Conservify, Arabata Initiative, Audio Moth, OpenROV, like all these projects were all open source. And now you're seeing some people that are like actually trying to create more proprietary business models, which like is totally fine too, and it works. That's a proven model, but like in terms of like open source collaboration across the board, conservation technologists are like actually quite great at it.
Yeah. Now, and I feel like a lot of that has come from the community that places like, WildNets. And so in talking about how you've made this makerspace, then what inspired Fieldkit? Like what is the pathway to kind of get to this? And I know that you're doing 100 different things, and we were just talking about it pre-stream, but in kind of this one, I don't want to say one size fits all, but it's almost in that sense of, could you talk then about the transition between this from this makerspace to Fieldkit?
Totally, yeah. So at Conservify, we have a bunch of projects that we work on, and we've always kind of our projects have varied quite a bit. We've had ocean conservation stuff. We've put things on glaciers and in rainforests and savannas and deserts and all sorts of all over the world. And one of the things that we were finding when we were doing all these different projects with different partners was we found that there was a lot of interest in just general environmental sensing, better environmental sensing. And so on some of those early projects, we were buying environmental sensors from people. We're trying to integrate them into bigger open source systems. And, we were kind of running into a lot of recurring issues. And part of the reason why is, a lot of times the way that sensor technology has been kind of developed in the past is, you you either have a company that wants to build a commercial solution for like agriculture or environmental monitoring and these sorts of things, and they'll create a solution, and whatever they create is like what's on the market. The users, at least from a conservation and field science perspective, don't have a lot of say in it. Or you'll have like these people who have developed their own one-off thing as part of their like PhD or in a lab at a university, and then they spin it off into a company, and that company then builds that thing and everybody uses it. And both those models are great for certain things, but they're really bad at making tools that are cutting edge, and they're really bad at making tools that are accessible to a lot of people. And so, we were doing a lot of work in the early days around how we can kind of reimagine how we do these sorts of sensor systems and use things like Arduinos and Raspberry Pis and like all that sort of tech that if you want to like learn how to make a temperature sensor with an Arduino, there's like probably 18
million
tutorials online about how to do that. And so we were thinking about those sorts of things and ran into the same sort of problems that everybody runs into when they do these things. They're not reliable. It's missing a lot of the important data behind it, like GPS and things like that. Power hungry. So through all that, we started like trying to understand how we can build a better system around that, a system that's open source, a system that's modular, that allows us to build a lot of our projects on. So the next time we want to, we have a project where we're measuring something in the environment, we can use Fieldkit as the backbone of it, but also allows other people to do that as well. And that's kind of where Fieldkit came from. It came out of work that we were doing in Botswana with National Geographic, and it was kind of the brainchild of me and this other individual, Jer Thorpe, who is a data guru and data artist. Jer used to be the data artist in residence at the New York Times and the innovator in residence at the Library of Congress, and he's done a lot of really amazing stuff. And so Fieldkit started as this collaboration between me and Jer to try and think through how we can reimagine environmental sensing in an open, modular, accessible way.
Yeah, and you mentioned it earlier, but it's really interesting because you talked about some of the traditional models, and like one of them is quite literally with the traditional PhD model of spinning it off into your own company. I think you hit the nail on the head is a lot of times those aren't universally deployable at all, because a lot of times it's this worked for Andrew, who does field work in southeastern South Africa, and I've built this perfect thing in 6 years that works for this one environment. And then, but through my PhD, right, I might have only been in that one location and didn't go to, all the other places maybe this species exists. And it's really cool to kind of see some of this develop. So when you describe Fieldkit, I know like on the website it has some of the main goals and implementations of it. Could you talk about like what makes Fieldkit different than in my opinion, it doesn't really have competitors, but in some of the previous opportunistic technology that has come before it?
Yeah. I mean, with Fieldkit, so there's a couple things we're building. One is we're building hardware, like data loggers, sensor modules, and then we have fieldkit.org has a data visualization platform, so that allows you to kind of like look at maps and charts and like play around with your data and send that to other people and bring in collaborators and do all that sort of stuff. And it has an app that we're building that allows you to kind of talk between the hardware and the website and do a lot of interesting sort of stuff with it. So basically what we're trying to do with the hardware is create these kind of modular and open systems. So if you want to get a data logger right now from like one of the major companies that are selling it, it's something that's going to cost you $1,500 to $6,000. And basically all it's doing is saving data. And so we created a version. This is our data logger. It's got an SD card and GPS and all sorts of stuff in it. And the cost of one of these things is like less than $100, right? And so you can basically get the same capabilities that these bigger systems have, but build it cheaply and open source. The other thing that we're doing is we're making it modular. So basically our data logger allows us to plug in all these different sensor modules, and each one of these things can measure a different thing. So this is a water temperature sensor. You can have pH, you have a weather station that operates off of one of these, or air quality.
And this is
anything you want.
That's the part that made my students think about it being like a KitchenAid. It's because you have these basically ports, and then if you need these 4 things, then it's for those of you that have built a desktop, it's very similar to video cards, right? And it's basically you just basically plug and chug in terms of the text.
And I mean, and like it's not limited to 4. We just have this 4 plate here, but we've also designed like an enclosure around it and all this other stuff, which I don't have near me, unfortunately, and a bunch of other stuff around that to support that ecosystem, allow you to deploy it. It's definitely different than anything else out there, because there's not another data logger out there that allows you to like easily, without any code, plug in let's say a particulate matter air quality sensor with a pH probe with an with a weather station, all on the exact same the same data logger. And since this is open source, people can take it and build their own things off of it. They can do all sorts of interesting stuff with it. And so so we have collaborators and stuff that we're working with that are actively deploying these, that they're like super excited about the different options that they get from that modularity. But it's also something that can be used by like students as like a learning tool with teachers, or activists that are trying to track environmental damage that comes from industry like oil or things like that, or it can be used by lots of different people doing lots of different things.
Yeah, I think some of the stuff that I think is so interesting about it is it's like the perfect avenue to get from the EWB to conservation tech, right? It's like this I mean, we talked about, wastewater treatment and some of these things that kind of started this, but what's so cool about it to me is just the aspect of it gets people excited about, the different environments. And part of what we've talked about a lot is, as engineers, a lot of times engineers ignore the biology. And the best part about it to me is you kind of have to understand the ecology and the environment around where you're going to deploy it to then understand what different parts that you'll need. And it's really cool to just the open source aspect of it. And yeah, I need to talk to I've been meaning to talk to some of the faculty members at Georgia Tech, because I think it could be something really easily as a learning tool in just ecology labs, because it's a really cool way to, because you talk about not having to code anything, of understanding the difference between ecology A versus ecology B and all of these different factors that go into it. And yeah, it's just really cool the model that you've used.
Yeah, I mean, we've been working with people right now, so we're deploying it in the across the Amazon rainforest with the Wildlife Conservation Society. We're deploying it in Montana with the American Prairie Reserve, in Panama with the Smithsonian, and in the Caribbean with MIT, and a bunch of different organizations. But one of the cool things that we did for Earth Day, for the 50th anniversary of Earth Day, is we gave away 50 of these things.
Yeah.
So we're mailing them out later on this year, but there's 50 sensors going to 26 different countries around the world where people will be using this to like answer their own questions and understand their own research areas that they're looking at, water quality and weather and all sorts of stuff.
Well, and that's one of the coolest things. So you back up a second, right? You talked about like the Amazon and like so I mean, those are just maybe places to some people, but all of those have super different environments, right? So some are more humid than others. Some have more, I mean, we've talked about you have factors like tree cover, how much, I mean, there's just so many different things. So the aspect of, I think it's really cool, the Earth Day that you did, because I mean, you said what, 26 different countries?
Yeah, 26 different countries.
Yeah, and so you talking about this universally deployable sort of thing, you have 26 or I guess 50 data points, but like you have 26 different, I mean, not guaranteed, but pretty different environments of different latitudes, longitudes, all of those different sort of things to get, for you to be able to, make updates or things like that, which is, I think, really, really cool that you're able to kind of have that footprint. So have you spanned, so how many continents have you actually tested it in?
So right now we've only tested it in well, the current version has only gone out just in like North and South America, but we're expanding. We've been basically developing this thing for the last 2 years, and those will go out. I think the 50 that go out go to everywhere except for Antarctica.
That would be a long trip,
which is pretty cool. But we have
really cool.
We have collaborators in Antarctica that are interested in using it. So eventually we'll get to Antarctica. I mean, I want my own personal goal is for it to be in on every continent and in every ocean by next year, just enabling people to study these things. I mean, the thing I get excited about Fieldkit is not. I mean, I get excited about the technology side, but it's the part that makes me most excited is how you can make these things more accessible to a lot of people. So most of the projects that we work with in Conservify, we're working like hand in hand with this with scientists that are in countries where they don't get the same sort of resources that scientists here in the US or the UK or the EU get, right? I mean, it's just the cost of everything, the amount that of grant funding that they get, it really limits the amount of work that they're able to do, which is like really disappointing,
And that's the thing is you touched on it before you go on. It is grant funding. The amount, like, that is a small grant, right? When you apply here, it's like, oh, it's a really small travel grant or something like that. That sometimes are the largest grants.
Yeah.
And so the difference between I think it was 1,500 to 6,000 piece of technology versus 100, right?
Huge.
Like is huge, because when you're just thinking of, and this is just really, really cool, is the development of this product, this technology, right? That is able to be not only universally deployable, but has the end user in mind universally, rather than just like domestically, such as, just looking at, oh, we're going to build something for ecology classrooms in the United States, but it can be used by that. It can be used by scientists in Antarctica, in Botswana, all of these different sort of things.
It's, I mean, also in my opinion, there's like major ethical things about it too, right? Like when the tools are that expensive, the only people who can afford it are the ones that come from like big universities, and these big universities have big budgets. They travel to, let's just say, for example, we're going to look at Virunga in the DRC. So like, if you have scientists that are in the Congo Basin that are at universities there, a lot of times they can't get the resources to buy those same tools that you have people at major US universities getting those tools and going into Virunga, gathering all that data. And typically the way that field science has worked for decades, for actually, hundreds of years.
Yeah.
Scientists go there, they gather all that data, and then they leave. They go back to wherever they come. And the community, the people that live in that area, the scientists that rely on studying those places every single day of their lives from the regions that they're working, they never get access to any of that data. And and so it perpetuates this kind of really like unethical. It's called parachute science, and a lot of my friend Asha calls it parachute science when she talks about it, because you have these rich researchers come parachute in, gather all this data, and then leave.
Yeah.
And that doesn't benefit the community. It doesn't benefit local scientists. But when you can create tools that are more accessible and available to those scientists, then you can change the way that situation is. You can build these systems that allow science to be done in country and not rely so much on kind of the charity of people opening up their data.
And that's what open source does. Yeah, and that's one of the I've never heard that term. That's the parachuting. And yeah, it's sad because I think we talked about this 2 weeks ago when Carly was on, but people were like, "Oh, how long is that? Like, when did that stop?" Like, and it's like I still read papers every day that it's like, "Oh yeah, so we went to Botswana, we took data on I'm just gonna make something up, 2,000 wild dogs. We thank our collaborators," and you're like, "Well, so how'd you find the 2,000?" Yeah, it could be a rant session, so we don't need to get there, but. The other part I'm curious about, and we talked about this a little bit beforehand, but what are some of the roadblocks right now? So what are some of the challenges that y'all have faced? And I know you've said it's been ongoing on the last 2 years. So what are some of the challenges you've faced in the past, and what are some of the ones that you're working on right now?
Yeah, I mean, I think I'll also talk about Fieldkit, but in the context of conservation technology projects, right? So these projects always face funding issues, and so we there's more foundations and organizations nowadays that are understanding the amount of work it takes to build a technology solution, and they're funding those appropriately. So for Fieldkit, we've been very lucky to work closely with the Gordon and Betty Moore Foundation, who have been great supporters of ours in that regard. So funding is always a thing. It's hard to find sustainable sources of funding. It's why a lot of people go to for-profit sort of examples. But one of the things I'm trying to prove with Fieldkit and Conservify in general is that there's sustainable ways to do nonprofit product development without having to constantly rely on philanthropy, which I have to this point, but we're right around the corner from proving out this idea of not being able to do it, like building a revenue generating nonprofit that can support research and development.
And so I want to, you said it, and I want to touch on it, is that the sustainability thing, right? A lot of times it's like you can get the startup and then like that is it, right? And then you're competing against, you kind of have this Shark Tank sort of thing for the sustainable. And that's kind of the difference. Is I feel like in a lot of this space now, it's very, I don't know, it's just very difficult to get past, kind of you get your foot in the door and then it just gets swept out from under you. And so the sustainability portion is really important, because in the conversations that we've had about, creating this tech that is, has this model of going into the field and adapting, right? A lot of stuff can't get done in 3 months. Mm-hmm. Like, no matter how many people that you have working in a room together, you need to go understand the environment, understand the community, understand all of those sort of things you talked about earlier. And it's really, and this is actually, and biology, it is difficult. Like, my main research, we're doing some stuff to see how elephants interact with their environment, and we had built this device, and then we put it in front of the elephant to see what it did, and it just broke the entire thing. Mm-hmm. Right? And that doesn't normally happen in a, I guess, traditional engineering role. And so a lot of people don't understand I'll just say the added difficulty that happens when you're doing surrounding anything that is not like controllable.
Well, and on top of that too is it's a little bit different um, within the academic world, because you have students and people who are studying that can kind of provide this sort of labor. But once you get out of it, we're not affiliated officially with a university. We work with universities, but we're not affiliated with one. Then, like, being able to find people to build these sorts of things is an expensive thing. I mean, engineers make a lot of money, especially once you get to like software engineers. It's crazy. I mean, entry level job as a software engineer at Airbnb is $238,000 a year, and that's just you're not going to find those people for conservation technology projects, which means you either have to find people who are willing to work for less, or find people who want to do volunteering sort of support, and volunteering has like huge limitations with it as well. But we've tried all those models at Conservify.
Yeah, that's one of the cool parts about like the digital makerspace, I think, is getting some people that might start in that voluntary role and then give them a chance to kind of come together. But yeah, it is. I mean, this is just a reality, is talking with people in the class, is they're like, oh, I'm interested in this, so and so. And then they get an offer for oil and gas at 6 figures. And they're like, I might be a little bit more, inclined. And so but I think the great part about that is everybody is motivated in this for the work.
Yeah.
Right. Is everybody that works in this space, I think, really, really loves the space and is really committed to it. So that is kind of an advantage of, it's kind of like grad school, right? Like everyone jokes, no one's in grad school to make money. There's a little bit of a difference, but, I've talked to, that's actually something that's very true just in machine learning. We got to talk about that a little earlier, as well as had some guests earlier, but with machine, it's the same thing as like a computer scientist. You try and tell them, oh, I use this for wildlife. And then it's like, well, or I could use this somewhere else for
self-driving cars or something like that. Yeah.
Yeah.
Yeah, no, there's a lot of people who want to do more with what they know, which is great. There's a huge amount of very passionate people, and it's fantastic. But doing it in a way, like it also, you want to pay people for the work that they're doing. Like you don't want to just kind of try and get free labor everywhere. At least I do. I try and pay people for the things that they do, and do that to the best of my ability, and then just spend extra time trying to fundraise for that to make that a reality. So yeah, that's one struggle that we run into quite a bit. The another thing that we've been faced with Fieldkit is it's like we're building a bunch of different stuff at once. We're building, software and data visualization, data management website. We're building an app. We're building, data logger, communications modules, sensor modules. We have I think at this point, 20 different PCBs in some state of either being complete and ready for distribution, or almost getting there. So it's a really ambitious project for my team to try and be putting on. And so that just gets complicated. Probably in hindsight, we probably should have just picked one thing, put up a store and started that and evolved from there. But there's lots we want to do. So,
but yeah. But I think that's one of the great parts is, there's all of this stuff, but right, it's already in places making an impact, right? So, this stuff it will just make the system better, but it's I guess the way that I think about it is like when you're downloading a video game and it's like, it's ready to play versus it's like 100% downloaded. I think the cool part is you're getting into that stage. So do you have some deliverable goals for all of this sort of stuff?
Yeah, this year we're right almost done with being able to put everything up online so people can see it and actually buy it if they want to buy it. It's all the documentation is not totally done, but like everything is open source, so like people can build their own if they'd like to build their own. But this year we're going to start selling them. If people want to just buy the completed product, they could do that. So we're going to have three sets of pre-orders in 2020, and then in 2021 it's just going to be fully open for anybody who wants to buy this and deploy it anywhere. And so right now we're in the midst of like, we just hired a community manager and we're building out that sort of system, and we're figuring out everything we have to do logistically.
So a lot of people associate the words open source with code. So could you talk about, like, with it being completely open source, what, like, I know you just said like, oh yeah, Andrew, if you want to build one, you can, but like, could you talk some about what that means?
Totally. Yeah. I mean, so open source is something that started at in the software world. So the history is kind of interesting. It started with free and open software way back in the early days. It really took off in software, and so a lot of the frameworks that build the internet are built on open source code. If you've ever used a Linux machine, that's all open source code. So the idea behind open source is you develop something, you from a software perspective, you write something, you write a bunch of code, a library or whatever it ends up being, and you put it online and other people use it. And as people find holes or bugs or figure out other capabilities that can be added to that software, they can go ahead and look at the full source code and end up like, adding in little bits and bops or making modifications. And you either have the option to take that modification and create a different version of that initial software, or incorporate it into that original software. And the tool that a lot of people typically use for this is GitHub. If you've heard of GitHub, for kind of collaboration and merge requests and all that sort of stuff that comes associated with that. So about 10 years ago, maybe a little bit beyond that, people started thinking through like how you can use that same approach but do it with hardware. Before then, hardware designs were mostly proprietary. There was a lot of like, very basic circuit designs that you could find for like little certain like pieces of circuits, and put those together into your own project. But it was around 10 years ago where people started thinking through like, let's create this version of open source but for hardware. So that's when the Open Hardware Association was founded, which full disclosure, I'm on the board of OSHWA. So but they started thinking through like, how do we take everything that software people have learned about open source and collaboration and bring it into people who want to build circuit boards and do that, and created the framework around that. So instead of just putting up your code online, when it comes to hardware, it will include extra things. So there's things like that's like a BOM, which is a bill of materials. So it's like all the little components that make up your circuit board. So it's kind
of like the way I always think of
recipe or something, right?
Yeah, it's a recipe, or like if you ever like get a piece of IKEA furniture and you look and it has like all of the stuff that's inside of that. It's kind of like a little bit of all, but in a hardware sense.
Totally. So and then there will be like design files. So it's the layout of all those things on this board. What this board file, they're called the circuit board files are Gerber files. So like what these Gerber files are shows like where all those different components sit on this board layout and what the different layers of the board are made up of and all that sort of stuff. A lot of times too with open source designs, you'll have mechanical kind of like CAD drawings, or when you're not talking about circuits, you can have like open source, enclosures and things like this. So this is like
a good example is 3D printed stuff, right? If you can go on somewhere and you can download the CAD file and all of those sort of things, and there's not like a paywall associated with it. But that's one of the cool parts, is this hardware open source portion, because the reality is, right, is if somebody is like, well, Shah, I just want to make my own. I mean, this is not a, well, no, buy it. It's a, great, make your own. Here's all of the files. Here's all of the thing that, I mean, I don't want to speak for you, but I feel like the part of this project that's really cool is it's not really about the product, it's about the technology, right? And that's and I might be getting that, that phrasing's correct, not backwards, right? And you really care about just this technology being implemented around the entire globe, not that a fieldkit.org bought product is on it's kind of the difference of having this universally deployable technology that is open source in all facets of both the hardware and software. It's really, really fascinating and cool.
Yeah, and and we want people to take it and build new sensor modules and create new functions and functionality out of it that we're not focused on right now for any reason. Maybe it's like further down our line, or we're not using it on certain projects, or whatever it ends up being. And it's this idea that like by us doing that, we're creating this like ecosystem of technology. If you've heard of like Arduinos and Raspberry Pis, it's a very similar concept, right? Where they created this board and then made the designs available to anybody, and people created add-ons and shields and all sorts of things that you can plug into these things to create really cool projects. And it's like basically became the backbone of other folks creating their own businesses or like research projects or whatever it ends up being. And so we hope with Fieldkit we can kind of build that same core ecosystem and then just let people go wild on it.
Yeah, it's kind of, you're giving the foundation level, right? And you have these things both on the hardware and software side, and you're just kind of, okay, everybody go. And that's kind of talking about the business side, right? That's the probably great part about sending 50 of them out is, right, you have these 50 different people that are, I think there's like an application form, right? And all of these people that are doing different sort of things in 26 different nations can then keep on contributing to these foundational groundworks that you have. And it's really cool. So the last thing I want to talk about before we go is, could you talk I've done a bunch of research on it, but I think it's just so fascinating. Could you talk about the app? Because I think it's so cool. Yeah.
So the whole idea behind the app was, a lot of times when people are interfacing with these sorts of things, they have to like, pull up a terminal on their computer or like all these other sorts of tools, and it just makes it not accessible to a lot of people. And so our idea behind the app was, this thing has Wi-Fi on it. We can just connect to it, and we can download data off it. We can change settings on the software. Basically, this has a little screen on it, but like the app allows you a much richer experience to actually change settings. And one of the things that we were thinking through with the app as well is a constant criticism you get out of these low-cost sensor projects is that they're not scientific enough. And part of that is because when they're being deployed, you don't really have a way to prove that you're deploying it in the right sort of way with the right sort of protocols, collecting the right sort of metadata, doing all this stuff that when other people look at that data, they can say like, oh, this is weather data that I can consider valid. I could use it in my research, or I can, actually make decisions based off of it. And so we've actually built that into the app, the ability to collect all that sort of information alongside of your deployment, so that when people look at your data, they're like, I trust this data. This is a pH sensor that's in the Amazon River, and not a pH sensor that's just sitting in someone's toilet somewhere or something,
Yeah. So people might not kind of understand like the scientifically viable, but I think the way I would describe it is it's like, oh, cool. So you went and bought a pH sensor, that doesn't have an accurate number of digits. It doesn't have the time that we sort of need to be able to report this.
Yeah.
It's
kind of, it's kind of, when scientists are doing, so if you're scientists that are studying dissolved oxygen in rivers, like those scientists typically say, we only trust data if it comes from these sorts of systems, if you do all this extra work around it, there's all these there's protocols that they build into the collection of that data. And that some of those protocols include you have to measure these sorts of things, like what's the time, the GPS point, what's whatever these extra things you have to measure around it. And when you have these citizen science projects or Arduino based projects that don't do all that stuff, then those scientists use it as a criticism to say, that's not real science. And that's probably totally wrong. It still is real science. But what we try and build into the app is a way to prove that even though you're using these tools that don't cost a lot of money, you're still doing real science. You're still doing something that matters.
And yeah, I want to add one kind of final clarification of that. So, and we've been in this industry, so we kind of know, but no matter what you're doing with Fieldkit or any other sensor, it is still science. Yeah. What we're kind of talking about is this sort of hierarchy that is the traditional, the academic faculty member that is getting peer-reviewed literature, that all of this sort of almost gatekeeping to that inhibits, I would say, some of the most fundamental things of just doing things like looking at water quality and those sort of things. And if you're doing that in the Amazon and a bunch of different places, you don't need 5 significant digits and a $150,000 sensor, right? That is to think of the actual meaning behind the work you're doing. So that by no means, do you need and we both know this, you don't need a $6,000 sensor to do science. It's just some of these things that have been, some of these barriers that have been built around this, which what I honestly do believe is I think as things become more open source, people will realize that that stuff's less necessary, because they'll look at, oh, hey, well, this open source data is from the exact same place and is comparable to a sensor that is 60 times its price.
Yeah. Well, and honestly, we're that's one of the things I hope Fieldkit will help. And so we're actually,
that's really cool.
We're working with academics to prove that, right? Where they're going to be putting Fieldkits next to those $6,000 thing, and they're going to show that that's not the case. This whole this whole phenomenon that we're talking about is kind of a way that older, more established scientists are keep new people from coming into their realm, right? Because they're only going to trust the people who have enough money to afford these big, expensive tools that they use. And anybody who uses anything different is just not real. It's just not valid. And so I'm hoping Fieldkit, my goal in 5 years when I look back is that I hope we've proved that a bunch of times, and that we show that these sorts of tools matter, and that you don't have to create this exclusive kind of club of what real science looks like.
Well, and I do think it will reduce the parachute science, parachuting work. But because the aspect is the people who do the best work are the people that are working with their with the species that they live around, right? And the United States has basically destroyed all of our characteristic megafauna besides bears. But if you look at it, what I think this will also really impact is a lot of projects of the native species, right? Throughout the world, a lot of people focus on this characteristic megafauna, and I think it will also increase some of the work on less, I don't know, sexy species. I mean, it's probably the best way to say it. So, man, I'm just so excited to see where this stuff goes. And I know you're infinitely more excited than I am, because you're getting to work on this stuff each day. But I really do, to kind of end here before we go into a book, but I really do commend your vision and your team, and I do mean this, because something that has always been difficult in 3 semesters of running this class is that so in making a lesson plan, as like a teacher, what you always want to start with on the very first day is a hook. It's just like when you read a publication and the first sentence is like, this X many people died of heart disease this last, and it's just like okay, well, I just heard a huge number. I gotta investigate that now. And I think a lot of your work is what makes it so cool. Is we talked about this community science and this sort of thing, but I think it's a perfect avenue between what the traditional, I'll call it a conservation engineer, which is centered around like this wastewater and all these, and it's a perfect gateway to investigating some other and more complicated things in ecology, more almost biology focused, which is, I think, in my opinion, conservation technology is much more biology focused in that sense than some of the other like traditional things like wind power is not, is technically conservation. But anyway, so I just commend the project and kind of the vision you have, because I really do think you've taken this model that is, like you mentioned earlier, Engineers Without Borders, and it's effectively able to get engineer. I mean, my class, we have, I think, 20 students this semester, and I think we have 12 different majors. And after seeing some of the stuff that you've talked about, it's really helped kind of that hook of getting people excited about this space. So because all the other stuff, right, is cool, but when you hear something like bioacoustics, that there's such a learning curve necessary to get to bioacoustics, and they go, okay, I understand bioacoustics now. But if you look at something like a Arduino, like a Raspberry Pi, and this sort of open source type of hardware, and then you say, now we're going to make something that has this open source and is purely for conservation tech, it's really cool, and it's a perfect example of the universally deployable product. So
yeah. No, thanks, man. No, I appreciate it. We're the whole team is super excited about it as well. And I'm really keen to see what people do with it. I want it to be out in the hands of folks and just see what sort of interesting. I think that's the coolest part about these sorts of projects, is that you could think about it for years, and with like multiple people throwing all these ideas at the board, and the first time it goes out into the world, you're just going to learn like 1,000 new ways to do.
Well, that's what will be
it,
funny for you, is you're going to be like, people are going to use it for X, Y, and Z, and then you're going to see something in a year, and you're going to be like, what the hell?
Yeah,
it totally works for that. And that's kind of the cool part of putting this universally. Is, I remember my brother told me that I think it was my brother or one of my brother's grad student friends, but they really wanted to make a sous vide machine, like one of those fancy water, and they made one with an Arduino. Mm-hmm. And it was a $300 machine, and they were able to kind of do some of this stuff with open source tech. Yeah. So this has been awesome. So the last thing that we'll talk about is a book, podcast, any sort of thing that you'd like to recommend, and I will be sure to link that to everybody. But do you have anything that you'd like to kind of share with?
Yeah, one thing. So I have a friend that I know through Nat Geo circles, this guy Kevin Peter Hand, who is pretty high up at JPL. He does solar system exploration stuff, and he came out with this book that's called Alien Oceans.
So cool.
Yeah, so it's basically, Kevin's work is all around mostly looking at Europa and kind of what lives inside of these things. And the cool thing is, like, they're gearing up for a mission that's going to be happening down the line around exploration of the oceans out there. And it's interesting from a conservation perspective, because if we can find any sort of weird life down there, it like changes everything. So,
well, and for those that don't know, JPL, Jet Propulsion Laboratory, it's affiliated with NASA. But that's, I assume that is the correct JPL that you were.
Yeah, that's the same one. Yeah, and I mean, if you Google Kevin Peter Hand, there's a bunch of like talks he's given about it and stuff online and on through like Nat Geo and things like that are just like absolutely fascinating. He's a really interesting guy. The other quick thing plug that I'll make that I haven't listened to it yet because it still has yet to come out is and I want to get it right. So hold on, let me. A friend of mine, Ayana Johnson, who is she runs this organization called Ocean Collective. She's a really inspiring person from a ocean conservation standpoint.
Oh, is this the How to Save the Planet podcast?
Yeah, How to Save the Planet. There's a new podcast coming out that she's doing with Alex Bloomberg from Gimlet called How to Save the Planet, which I think just came out. So everyone should listen to it.
Yeah, I linked I linked the podcast. They did an intro one on Spotify that I got to listen to. That was about 3 minutes long.
Cool.
But yeah, so thank you so much, Shah. I'll say goodbye to everybody. Have a good weekend. Good luck with waking up at 5 a.m. For family things with your little one. So it's good to see you as always. So talk to you later, Shah. See ya.
Cool. All right. Bye, everyone.